So friends, welcome. I'm going to briefly discuss today some of the probability concepts. And whenever we hear the term probability, I find students very concerned about the concept. But let me assure you, it is one of the building blocks for whatever you are going to subsequently do. You are going to talk about probability distributions, and you are going to use these distributions to speak about theory of estimation. You are going to talk about this for testing of hypothesis. So this is the primary basic concept. So let me begin. Why I said that this is a very simple concept, because there has been not much change in what was taught 600 years back and what is being taught today. So my friends, what are we going to discuss today? We are going to discuss today what is probability, what is classical, empirical and subjective approach to probabilities, some of the common terms, events, outcomes, permutations, combinations, what is the concept of conditional and joint probability. We are going to look at a tree diagram to solve a Bayes theorem problem. Besides this, we are going to talk about the addition theorem and we are going to talk about the multiplication theorem. So, what is an experiment? What is an event? And what is an outcome? So maybe we can say experiment is throwing a dice. What could be that event? Whenever I throw a dice, it will be either 1, 2, 3, 4, 5 or 6. So these are known as all possible events, all possible outcomes. And if at all I want to have some combination, probability that it's an even number, probability that it's an odd number, so this could be termed as some possible events. Now, whenever we are talking about approaches to probability, there are only three. The first one is what is called the classical approach. So the classical approach assumes that you know the probability of every outcome. So whenever I'm going to toss an unbiased coin, there is a 50% chance it will be a head, there's a 50% chance that it will be a tail. So this is the foundation of classical probability, that you know all possible outcomes and you also know that it is going to be a fair play. However, there are some situations where you may not know all possible outcomes, or you may not have sufficient information from the past, or in other words, you might have to experiment to get an information, and this is what is called the branch of empirical probability. So let us consider NASA has sent 115 missions to space, out of which 113 have been successful. Now it wants to launch the 116th mission. What is the chance that this 116th mission would be successful? So we look at the past data. Out of 115, 113 were successful. So the probability of the 116th being successful is going to be 113 divided by 115. And in all of these calculations, what you would have just noticed is that the probability on the minimum will always be 0, on the maximum will always be 1. It cannot go below 0, it cannot go beyond 1 when you are operating in the same space, the same subspace. Now, the third branch is what is called subjective probability. What is the probability of India winning the next World Cup? Now, we might have data, you might have done a lot of analysis, but still the decision is going to be on the basis of your gut feel. And this is what is called subjective probability. Next, we have just two theorems when it comes to probability. The first theorem is called the addition theorem. And when we are talking about addition theorem, it is interesting to note whether the events are mutually exclusive or not. What do I mean by mutually exclusive? If one happens, the other will not happen. When they are not mutually exclusive or they are overlapping, what it means is one happens, the other will happen, and there can be a small overlap. So consider a small diagram where we have got event A and event B. In the first instance, there is no overlap. That is called mutually exclusive. So now, probability of A or B. Remember, addition theorem will be OR. The notation is going to be union. So probability of A union B or probability of A or B is simply going to be probability of A plus probability of B. But if there is an overlap, now what do you see here? The overlapping part has been once added with A, the overlapping part has again been added with B, so should I not subtract it once? And therefore, when there is an overlapping event, probability of A or B is equal to probability of A plus probability of B minus probability of A and B. Now, the A and B is part of your multiplication theorem, which means in your entire probability, you either have an addition theorem where we speak about or you have a multiplication theorem where we speak about and. So whenever you have any question in probability, please convert it into or, if not or, and. There is no third alternative. So therefore I always believe that probability is going to be simple, because whatever be the question, supposing I say both the students get selected, so convert this as A and B getting selected. If I say either one gets selected, so it will be converted into A or B. So whatever be the question, use or, if not or, use and you can solve any complex problems from probability. Likewise, what is the multiplication rule? Now in this case, we are going to talk about dependent and independent events. Let me explain. Supposing I got a box of 100 mangoes with 10 mangoes being rotten. Probability of the first mango being rotten is 10 divided by 100. What is the probability of the second mango being rotten? Depends on whether the first mango was rotten. If the first mango was rotten, then it is going to be 9 over 99. But if the first mango was not rotten, it is going to be 10 over 99. And if at all the events are independent, then probability of A and B is simply a multiplication of probability of A into probability of B. But if at all they are not independent, then we introduce what is called a conditional probability. So probability of A and B is going to be probability of A multiplied by probability of B given that A has happened. It is not B divided by A, but it is read as probability of B given that A has happened, and by extension, since it's a multiplication theorem, the answer would be same if I find out probability of B multiplied by probability of A given that B has happened. So this is the multiplication rule, and the last one is what is called the Bayes theorem. It is a theorem when some additional information is given, or this is a theorem for revised probabilities, also known as the theorem for posterior probabilities. In simple words, probability of A given that B has happened is going to be sum product of probability of A into probability of B given that A has happened divided by all such probabilities. So when we are going to solve one or two problems, this Bayes theorem is going to be very clear. It is extra simple, but for that we need to have a live session where we are going to understand the application of Bayes theorem and how it works. The Bayes theorem can also be solved by using a diagram which is called a tree diagram. So let me show you an example. So we have got three suppliers A, A1, A2, A3, and A1 will supply good or bad, A2 will supply good or bad, A3 will supply good or bad. So now if I say there is a bad, what is the chance that it belongs to A? This is your revised probability. So giving you the extra information that something is bad is the revised probability problem. So Bayes was a priest who wanted to prove the existence of God by proving the absence of God, and 1 minus absence of God meant presence of God. But in any case, this is a very useful theorem which is what can be used in many